Hi everyone. In this section we can discuss about a power screw based problem. I can read the question. Please listen. A square threaded power screw has a nominal diameter of 30 mm and a pitch of 6 mm with double threads. The load on the screw is 6 kN and the mean diameter of the thread collar is 40 mm. The coefficient of friction for the screw is 0.1 and the collar is 0.09. Determine first one, torque required to raise the screw against the load. Then second one, torque required to lower the screw with the load. Then third one, overall efficiency. And then fourth one, is the screw self-locking. Okay. Now we can discuss about the given data. What are the given data they are given? Nominal diameter is given as 30 mm, pitch given as 6 mm. Then number of threads. In this question they are given that it is a double thread, so we can write it as n is equal to 2. Then the load we can write as W is equal to 6 kilonewton. Here we can write it as 6000 Newton. Mean diameter of the collar DC is equal to 40 mm. Screw friction F is equal to, that is the coefficient of friction of screw is equal to 0.1. That of collar is equal to 0.09. It is denoted as FC. Then they are asking about TR, TL and efficiency. Then self-locking. First of all, we can calculate TR, that is the torque required to raise the load. How we can calculate? The equation is directly given in our data book. From our data book, page number 135, equation number 9.12a, given TR is equal to W by 2 D2 into F plus tan alpha divided by 1 minus F tan alpha plus FC into DC. Here we need the value of D2. How we will calculate D2? D2 we can take from this equation, that is D2 is equal to D minus D by 2, or we can substitute all other values, that is D is equal to 30 mm, P is equal to 6, then we will get D2 is equal to 27 mm. Now we can calculate lead angle alpha. Okay, this value we will get from the equation 9.10b, page number 133 from our data book. What is that equation? Tan alpha is equal to L divided by pi into dt, that is equal to NP divided by pi into D2. Here N and P are given. Then D2 we already calculated. So alpha is equal to, we can find out the alpha is the tan inverse of this value. That we can substitute all these values in the above equation TR, then we will get the value of TR, that is equal to 30,642.27 Newton millimeter. Next they are asking about TL. Again we can substitute the value W by 2 D2 into F minus tan alpha divided by 1 plus F tan alpha, that is the main difference for F, TL and TR. Then if we substitute all these values, we will get TL is equal to 7485.4 Newton millimeter. Next we need to find the value of efficiency. What is the value? Eta, efficiency is equal to D2 tan alpha divided by D2 into F plus tan alpha divided by 1 minus F tan alpha plus FC dz. This value or this equation we will get from data book, page number 135, equation number 9.12b. We substitute all these values, then we will get eta is equal to 37.4 degree 4. That is the efficiency. Then next one, last question is there, self-locking. How we will find that self-locking? We can state that since the efficiency of the screw is less than 50%, so the given screw is a self-locking screw. Okay. This is the first question. Next we can move to the second question. Again it's a simple question. I can read the question. A single start square threaded power screw is used to raise a load of 120 kN. The screw has a mean diameter of 24 mm and 4 threads per 24 mm length. The mean collar diameter is 40 mm. The coefficient of friction is estimated as 0.1 for both threaded and collar. Then they are asking about determine the major diameter of the screw. Second one, Estimate the screw torque required to raise the load. Again, TL they are asking, TR. Then estimate overall efficiency. Then fourth question, if collar friction is eliminated, what is the minimum value of thread coefficient is needed to prevent the screw from overhauling? So these are the given data. Number of starts, that is n is equal to 1. Then load is given, W is equal to 120 into 10 raised to 3 Newton. Mean diameter is given, that is D2 is equal to 24 mm. Then the number of thread is also given. We can write it as N1. Write it as N1 is equal to 4. Thread length Ln is equal to 24 mm. Then DC is equal to 40 mm. We can write the coefficient of collar, friction of collar and screw is equal to 0.1. Now we can find the major diameter. How will can find the major diameter? We already know that D2 is equal to D minus P by 2. Here the Ln is given. Ln is equal, we can get the value of Ln is equal to N1 into P from the page number 135, equation number 9.13b. Then if we substitute Ln and N1 there, we will get the value of P. Here the P is 6 mm. If we substitute that value in the first equation, that is D2 is equal to D minus P by 2, then we will get the value of D is equal to 27 mm. Then second question, they are asking about the torque required to lower the load. That is TR. How we will find the TR? TR is equal to W by 2 into D2 into F plus tan alpha divided by 1 minus F tan alpha plus FC into DC. That is also in our data book, page number 135, equation number 1.2, 9.12a. Then, in this case, we need to find the value of alpha also. How will we find the alpha? Tan alpha is equal to L divided by pi d2 or NP divided by pi d2. Here, N and P are given, D2 is already given. So we will get the value of tan alpha is equal to 0.0796. If we substitute all these values in the previous equation, we will get TR is equal to 500 into 500.7 into 10 raised to 3 Newton millimeter. Then next one, efficiency. Again from our data book, page number 135, equation number 9.12b, we can calculate the efficiency using this equation. Eta is equal to D2 tan alpha divided by D2 F plus tan alpha divided by 1 minus F tan alpha plus FC dz. All data are given. So we will get efficiency eta is equal to 22.90%. Then last question, minimum value of, we know that the condition for overhauling, what is that condition? Phi should less than alpha. Here tan phi should less than tan alpha or tan alpha should greater than tan phi. The minimum value to prevent overhauling screw is F is equal to 0.0796, the coefficient of friction. So that is the condition we have to state. Okay, thank you.